Welcome to my YouTube channel. I'm Kant, and today we will be learning about introduction to deep learning. So, why deep learning is very important? So, in order to understand it, we need to understand a small concept called as why deep learning. So, now in order to learn about what is deep learning, first you need to know why deep learning. And we all, for example, people who are into data science and people who are into AI, they say, hey, we are using machine learning or we are using deep learning. Even if you see various phone manufacturers as well, while they're giving their presentation, we used machine learning to enhance your image, or we used machine learning to recognize the people. But within the machine learning, we got a separate division called as deep learning. Now, if you are using ChatGPT, or if you are using voice assistant, or if you are trying to use any of this, I think without deep learning, those things may not be possible. So why someone need to learn deep learning? Now, as people who are learning data science or even data scientists, most of their career, they try to rely on older algorithms, or we are able to call them as machine learning algorithms. And there is a problem with machine learning algorithms. What is that? As your amount of data increases. Now, if we are in an environment where we are generating a huge amount of data, or we can call it as a big data, we are generating huge volumes, huge velocity, and huge varieties of data. Now, even though the data is increasing, up to certain extent, the performance of your machine learning model increases. And even though you are trying to provide more and more data, the performance of your machine learning model is remaining more stable or stagnant. That is one of the limitation of your machine learning models. And the second one is your machine learning algorithms are purely designed to handle a tabular data, especially like Excel data or a structured data. So I can take my banking data and I can say whether a customer is a churn customer or a non-churn customer. Or I'm able to take my recommendation data, I can build a recommendation engine model. Or I'm able to take my regular text data and I can say whether it is a spam email or a no spam email. But the challenge is, as you are providing more and more data, but still the intelligence power of your machine learning algorithms, they are not increasing. For that reason, in order to make it more intelligent, we are knocking the door of deep learning algorithms. So now what we are doing in a deep learning algorithms are, if you are trying to take this example, as the data increases, the performance of your deep learning model is increasing. So that is one. So why, as the performance of your deep learning model is increasing, so deep learning models are more like a human. Now, if you are able to take an example, now I'm trying to learn this deep, whatever the video you are watching, you are trying to learn it. Let's say this entire duration is 8 hours. So even though your entire video duration is 8 hours, you cannot grab the entire 8 hours content at a single stretch. So what you are doing is you are dividing this content into various parts, means every 15 minutes, or you are dividing that 8 hours content into 15 minutes each. In this way, by dividing it, what is happening? You are able to gain the knowledge. So even though you are learning 15 minutes each for 8 hours, even though you cannot grab the entire stuff, so we are calling taking this 8 hours and dividing it into multiple parts. We call it as batch size. We call it as batch size. And even though you learn it for one time, it doesn't suffice. So this entire 8 hours you're watching for one time, it may not be sufficient. So you want to re-watch this content for multiple times. So we are calling that as epoch. So the same video, you're watching it for 10 times, 20 times, or 30 times. Then you are able to grab it. Even you can memorize the topic that's going to be inside your brain. We are calling it as epoch. So humans are able to gain the knowledge. As you are keep on iterating for multiple times, you are able to gain certain understanding. That's the reason people say, hey, practice makes a man perfect. Why they are saying practice makes a man perfect? As you are keep on iterating, your brain is able to solve the mathematical equations, or your neurons are able to learn it better. So by while your neurons are learning better, you are able to understand the topic better. That's the reason, take a coffee, take anything, as you keep on consuming it, your brain get used to it. Why? They are able to grab certain information around it. The same thing with a game, the same thing with playing. As you keep on doing it, you're gonna be more experienced in it. Means you're able to gain the knowledge. The same thing with your deep learning algorithms. So in a machine learning algorithm, you have a mathematical equation, you pass a data, it solves it, you're able to get the outcome in hardly within few hours or few minutes. But in deep learning, it's not like that. It's same like a human. So deep learning is made up of various artificial neurons. So if you take a human brain, there are biological neurons, the same phenomena which we are able to see it in a biological neuron, we are trying to mimic that inside a deep learning, and we are designing that neurons as called as artificial neurons. So what is this artificial neuron, how they work? We will be discussing about those artificial neurons in our upcoming class. This is our artificial neuron. We will be learning about this in our upcoming lectures, so you don't need to worry on that part. And then when we are going into our deep learning, again, if you are trying to build a deep learning model, there are two ways of building it. One, if you take your ML, I can build my ML model using CPU computing. Why? It's a very simple. Even though you are providing more data, so you just pass the data, you solve it, you are able to get it. But there is no need of parallel processing in your machine learning algorithms. The reason why, your machine learning algorithms may not follow the concept of batch sizes. Some algorithms follows it. If you take random forest, they follow a concept of batch, but they are doing everything in a parallel. And if you are able to go back to your gradient boosting, again, they are not going in a batches. They are trying to learn everything. So multiple times, they are doing multiple iterations. Again, if you are using deep learning algorithm, like especially gradient descent algorithms, or if you are trying to use like gradient boosting or random forest, maybe they're going to come a concept like parallelism, but not needed especially. But if you are trying to take any of your deep learning algorithms, there are different levels of deep learning algorithms. Now this is called ANNs, artificial neural networks. Now if you take cockroach, and if you take rat, and if you take a dog, for example, the three things, and a human, now cockroaches are having a very limited amount of neurons. As the neurons are limited, the intelligence power of your cockroaches are limited. And on the next level, you have a rat. So there are even limited number of, there are some higher number of neurons than your cockroach, but still the intelligence power is limited. And again, when compared to dog, it's not like a human. The reason the number of neurons in the dog are limited than a human is having. So as the number of neurons are increasing, the intelligence power of your models are increasing. So if you look at this example from Google, if you look into this, now they collected 8 billion parameters, a neural network of artificial neurons of 8 billion neurons. And by using that 8 billion, they are able to come up with language understanding, they are able to come up with arithmetic, they are able to come up with question answering. And as they are increasing the number of parameters, now for example, now we are able to get 27 billion parameters. Now they are able to even add summarization. So again, if I just increase it, so 60 billion parameters, now we are able to get code completion, we are able to get summarization, we are able to get translation, we are able to get common sense reasoning. So again, if I'm trying to increase the number of parameters, so to like this is overall like 540 billion parameters. Now it can do a lot. So it can do a lot. Now it can do question answering, semantic parsing, proverbs, arithmetic, code completion, general knowledge, reading comprehension, summarization, language understanding, physics QA, joke explanation, dialogue, translation, a lot. Now, as the number of neurons are increasing, the ability so to do various tasks increases. Now, if I want to build this level of neurons, and humans don't learn it in a single go, they want to learn the entire information in a batch wise. They want to learn the entire information so across multiple times. Now, how can I increase the speed of this learning? Now, as we said, now the power of your deep learning model increases. So this is your ML model. If I'm trying to take a smaller model, again, it's going to be a bit like ML. Up to a certain extent, the accuracy of your neural network increases. After that, it's going to be stagnant. Small neural networks, or I can say smaller size deep learning models. And again, all right, I'm trying to increase the size of your model. So again, I made it a bit bigger. So we can say medium neural networks, or I'm able to call it as medium deep learning model. Now again, it's going to have a better, as the data increases, the performance increases. Again, at a certain point, again, it's going to be stagnant. So the performance of your deep learning model increases on two bases. One is it increases based on the amount of data. The more data you provide, for example, I can scrape the entire internet data. If I feed it into GPT-10, it can be more intelligent than the current GPT model. But in order to build this data, for example, if I want to build an intelligence of the entire internet data, I want to have a bigger deep learning architecture. Why? In order to accommodate this level of information, I cannot call a cockroach and I cannot teach this deep learning syllabus to them. I cannot ask a cockroach, come on, write a code on Python. It cannot do that. Why? So that level of neural network is very small. So based on that level of neural network capacity, cockroach can do only that level of task. So as the neural network sizes are increasing, the capacity of a task a person can do increases. Now, as we are trying to collect more data, if I want to make my deep learning models more intelligent, I want to build a bigger deep learning architecture. For example, you want to build what? A bigger deep learning architecture. If I want to build a bigger deep learning architecture, it's not that easy. I cannot just go and I cannot build a bigger deep learning architecture. If I want to build a bigger deep learning architecture, the training time increases. So what exactly increasing? The training time is increasing. Now, for example, in order to I want to build ChatGPT, for example, 10. If I want to build it, I want to select a bigger deep learning architecture. For a bigger deep learning architecture, again, you want to select the right optimizer. Again, based on the problem you are selecting, you want to research on the right optimizer. You want to research on the right loss function. You want to research on the right activation functions. So these three things are the very important layers. So now you need to select the right optimizer, a loss function, and an activation function. Apart from that, the architecture. For example, if you take GPT, there is a concept called as self multi-head attention, or we can say multi-head attention layer, we have it, or masked multi-head attention layer, we have it. Again, we got a batch normalization, layer normalization. In this way, various combinations are helping us to make your algorithms to learn better. Now, you need to work on the right deep learning architecture. All right, I'm not going into the technical part of it. Even though I have a data, I got a bigger deep learning architecture. Now, in order to build it, it is taking, let's say, 2 years of time. Hey, I cannot wait 2 years of time. Why? I cannot wait 2 years of time to get my model to release. Why? Before that, a lot of business can release even a better GPT version. Then what will be done in order to reduce that 2 years of time? I want to use GPUs. So graphical processing unit. So now why you are selecting a graphical processing unit especially is, so graphical processing units helps us to perform the parallel processing. So now your data, your neural networks learn it in a batch wise, means like portion wise. It can't learn the entire 8 hours at a time. It is dividing that 8 hours into 15 minutes or 30 minutes, and you are trying to complete it. So now another way is like you are, even though you completed entire series at one time or this entire video one time, in order to gain the knowledge, you want to keep on iterating the same topic multiple times. We call iterations. Now, the more and more it iterated, you are able to get a better learning, or we got a better loss value. So we will be discussing those technical later. Now, for that reason, in order to do that, so in order to speed up the training, we want to achieve a process called as parallel processing within the various GPU cores. So for that reason, we are knocking the door of GPUs. Now, as in order to have a lesser training time, what I need to do? I want to go for more GPUs. As the more GPUs increases, the budget increases. That's the reason if you are able to take, I want to build a 405 billion parameter neural network. If I want to build a 405 billion GPT model or something, then I need to have more GPUs. As the GPUs are increasing, the cost of your model is increasing. As the cost of your model is increasing, I want to get this cost. So no one want to invest on the deep learning model for the sake of investment. They want to make a return out of it. For that reason, if they are investing, for example, 100 CR on the GPUs and on the researchers or on the computer engineers, then how I am able to grab the money? For that reason, what they are doing, they are going with a subscription policy. So I don't want to get into that business right now. Now, if I want to make my models to get the task done in a lesser time, I need to have what? GPUs. That's what you are able to see here. Now, when you are able to take one GPU, the training time in seconds. So now when you are having one GPU to train a MNIST data, it is an image data. So by taking GPU, you are having a lesser time. Without a GPU, you are consuming a lot of time to complete the same task. And on the another side, by taking one image, you are able to train closely like 1 1000 images per second. By having two GPUs, you are able to train closely like 2000 images per second. By having four GPUs, you are able to train 4000 images per second. This is also again on another image based data where per second, how many images you are able to train it. Now, these numbers are helping us to understand. So, by having a GPU, you are able to make your deep learning models to learn better. And why you are doing that? To achieve parallel processing. Why you are achieving parallel processing? The deep learning structure is in such a way. So now when you are able to take any of the deep learning models, so now you need to optimize your batch size, you need to optimize your learning rate, or and as well as there is another one called as iteration. So these three are very important, and you need to optimize these three things, and you want to achieve a very good amount of performance. To do that, you need to knock the door of GPUs. That is one of the major pricing point of your AI models. Why AI models or why AI companies are charging money? So now people say, hey, I want a free tool. If you are going with a free tool, the intelligence power of that AI may not be that great. If you want a higher intelligence, absolutely, you want to pay some dollars to it and you want to get it. Now, our goal is not to know about this, and you are able to understand. So now, as you are trying to go with your machine learning models, they may not be good at accuracy. Even though you have more data, the performance of your ML models may not be good. As the data increases, if your performance need to increase, deep learning is the only way. That's the reason image recognition model, audio, or generating a video based on a text, or generating means like modifying your audio to a better version, removing noise and etc., making your images high quality, recognizing the people from the images within the cards. So all these are possible only because of deep learning. If you are able to see chatbots like ChatGPT, Gemini, any of this, they are possible with the help of models like deep learning. You are able to see coding, deep learning. You are able to see code correction, deep learning. All this which we are able to see right now in our day-to-day life is because of deep learning. Now, there within your GPU computing, we got data parallelism. So you can do that parallelism based on data, or you are able to do model-wise parallelism. We'll be discussing them as we move ahead. And then we discussed about this 8 billion parameters. And now these are different AI tools. When we are getting into deep learning, we all say, hey, when we say AI, we say about ML or DL. Hey, we are using AI, which is even ML or DL, most of the people refer. And if you are trying to go into AI, there are various categories within AI if you look into it. So I'm able to build an intelligence using machine learning or deep learning. I can build an artificial intelligence using machine learning or deep learning, or I'm able to perform intelligence using search algorithms. Mostly search algorithms are used in gaming. For example, I want to build a bot where exactly it is playing a chess game or it is playing various games. I can use search algorithms, or even for pulling out the right articles while you're searching in the Google, we are able to use the search algorithms. And we got again game theory. Mostly game theory is used for Google bidding strategy. Now it is trying to study how exactly other agents are behaving. So now based on that, it's mostly used for your bidding strategy, which is going to be called as your game theory. And we got knowledge representation. So this is used in order to build a semantic meaning. So like it is having a concept of nodes on the edges, where in order to draw the semantic meaning out of the document, or it can be for your drug related information, yes, I can use knowledge representation. And I got a probabilistic graphical models, so which is another category. So by using this probabilistic graphical models, where exactly we are able to build various stochastic models, and we are able to solve various stochastic issues with the help of probabilistic graphical models, with the help of graphical representations. And then we got planning algorithms, which are very much used in lines of your autonomous vehicle. So in order to take you from point A to a particular means like point B, so you want to travel from point A to point B, or a point C, or a point D. In order to do it, you want to perform localization and you want to plan your steps at multiple areas. So in order to do that, we are having a planning algorithms. So we will be discussing even about them in a high level, about the math behind search algorithms, what mathematicals we have it, and different categories of search algorithms, and the applications of search algorithm, game theory, and all this. At a high level, I will be demonstrating it. But out of all these AI algorithms, one of the highly popular right now currently is your deep learning algorithm. So most of the research is happening around deep learning, and most of the evolution is happening around deep learning. So the game of research of ML is stopped in 2010, And from 2010 till now, everything is research happening on deep learning. And there are different categories of your deep learning algorithms, especially. Now, this is your regular deep learning architecture or a basic neural network architecture. We call feed forward neural network. This is your input layer. This is your hidden layer. And this is going to be your output layer. And if you take an information like x1, x2, x3, in order to pass the information from one input layer to your hidden layer, you need to have a particular weight. So now the equation at hidden layer 1 going to be w1 x1 plus w2 x2 plus w3 x3 plus bias. So again, at a hidden layer 2, again, or if I want to write it at a hidden layer 2, the equation going to be w4 x1 plus w5 x2 plus w6 x3 plus b2. In this way, we are able to write down these equations. We will be learning about them later. So why the information need to flow from one layer to another layer, how it is learned, I'll be doing it on the next lecture. And the one area which you need to remember, very important, is there are different varieties of deep learning algorithms if you take. So each deep learning algorithm is trying to perform each type of activity. Example, there is a feed forward neural network, which is used in order to understand especially your tabular data. And it can perform very good on your tabular data. If you want a very good performance as the tabular data increases, you want to have a better learning, feed forward neural networks are good. For example, I want to build an image recognition model, I can use convolution neural network. So what is changing between feed forward, CNN, is the model architecture. And again, if I want to build a sequential understanding, I can use RNNs or LSTMs. And if I want to build ChatGPT kind of intelligence, I can use transformer models. And if I want to build, for example, graphical understanding, so now I need to build that knowledge representation, or I want to build that especially network analysis, or I want to build that drug DNA identification or DNA identification, or the next maybe like drug discovery. For all this, I'm able to use graphical models or graph neural networks. And if I want to build images, I'm taking a less quality image and I'm generating a high quality image. To do it, I can use diffusion models. So now in this way, we have different categories of it. If you want to change the background of an image, you want to keep the front same. And if you want to change the background of an image, you're able to use neural style transfers. In this way, like you have a different categories of neural networks. With all these neural networks, you are able to do a lot. And still, there are a lot of neural networks are getting into the environment. For recommendation engine, now people are using restricted Boltzmann machines. In this way, there are different categories of neural networks coming into the picture. So why? As the data increases, the performance of your neural network model increases or the deep learning model increases. Now, deep learning is one of the very, very important syllabus. The more you learn it, I think you are getting close to solving various AI related issues so into the industry. So now in a real-time industry, you may not find only a tabular data where ML data scientist people or machine learning people are solving it. But deep learning is trying to solve a lot of unstructured levels of data. So if you want to learn more about deep learning, and if you like this video, and if you have any doubts on this particular class, whatever we've gone through, please share your views in the comment section below. And if you want more kind of content like this, please do share it in the comment section so that I can make more videos around it. And we will be continuing this deep learning series. So in case if you are new to my YouTube channel, please do subscribe to it. And see you in the next video. Thank you so much.